Good morning, students. Students, today we are going to see about the next chapter, that is chemical bonding. Okay, before entering into the lesson, we can see the introductory part. So, students, already you have studied about matters. Okay, matters are made up of what? Yes, atoms are building blocks of what? Matter. All the matters, that is maybe a solid, liquid, gas, all the three kinds of matters are made up of what? Atoms. Okay, from this we understood that atoms cannot exist as independent one. They are dependent. Atoms cannot exist free in nature. Okay, here I mentioned that atoms cannot exist as independent. All they are dependent. From that means atoms cannot exist free in nature. So they have to combine with each other to form a molecules. Okay, well, students. So atoms cannot exist free in nature. So they are called as what? They are independent. Okay, they cannot exist free in nature, so they depend upon each other, so they combine with each other, except a group called noble gas. Except noble gas, remaining all the atoms, they are dependent. Hence they combine with each other and they forms what? Molecules. Okay, and these molecules are combined by a force, that attractive force only we will call it as what? Bond. We will call it as what? Bond. Okay, so atoms are the building blocks of what? Matter. What are the three kinds of matter? Solid, liquid, gas. All these matters are made up of what? Atoms. From this we know that atoms cannot exist free in nature. They are dependent. Atoms always dependent with each other. So they combine with each other. Atoms in the atmosphere and the nature, they combine with each other to form molecules, except a group that is called as noble gas. In modern periodic table you studied, isn't it? The last group is comprises of what? Noble gas. Except this noble gas, can you say some example? Neon, argon, krypton, isn't it? You can see the periodic table, the last group, 18th group, fully it is comprises of what? Noble gas. These gas, they never combine each other and they are independent. Only the noble gases are independent. Remaining all the atoms that present in the atmosphere are dependent and they form what? Molecules. And these atoms are stick with each other by a force of attraction, that we will call it as bond. For example, garland, isn't it? While tying, what we will do, you will connect all the garlands, or all the flowers in the garland is connected or tied together by a rope, isn't it? So that rope only handle all the flowers together. If you cut the rope, we can split the flowers, isn't it? So similarly, here also each atoms are held together or hold together by a force or attraction between the two atoms. That only we will call it as what? Bond. Okay. Have you understood, students? So the atoms, they combine together to form a single unit and they are held together by a force. That force is called as what? Bond. Example, you can imagine the garland. The flowers in the garland are tied by a what? A rope. If you cut the rope, what will happen? The flowers can be split. But all the flowers are tied by a rope. That rope only holding all the flowers together. Like that, here also the bond only tie or hold these atoms together. Okay, so from this we can define the chemical bond. What is chemical bond? A chemical bond is a force of attraction. It's a attractive force. It is a attractive force. It's a force of attraction between the atoms which make them together. So what is bond? Bond is a force of attraction that keeps two atoms together. Okay, that is called as what? Chemical bond. That is called as chemical bond. Okay, so we know that atoms combines with each other to form a molecules, and the molecules are kept as a single unit by the help of this chemical bond. Okay, any doubt in this? So once again, what is chemical bonding? Chemical bonding, before that, atoms cannot exist free in nature, so they all are dependent. So they combine with each other except noble gas. While combining, these atoms forms molecules, and the atom in these molecules form a single unit, and this unit is held by a force of attraction. That force of attraction we will call it as what? Bond. Okay. Next we are going to learn about Kozal and Lewis model. How Kozal and Lewis explained about chemical bonding. Okay, so this Kozal and Lewis, according to them, they have answered for 3 questions. Kozal and Lewis has explained the formation of chemical bonding. Okay, before that, we can arise 3 questions. I said atoms are what? Cannot exist free. Why they cannot exist free? Why the noble gas? From this you also get the doubt, right, students? You might ask why noble gas can exist free whereas other atoms cannot. So that is the first the question which arise in chemical bonding. Why do atoms combine? What is the purpose of atoms to combine? Why they cannot exist free in nature, isn't it? Oxygen atom, why they are forming oxygen molecule, oxygen gas? Why they are existing as oxygen gas? Why they cannot exist oxygen atom? Okay, how they are combining with each other? How do one atom combine with the other atoms? The last question, why the noble gases are not combining? How that? What probability they are existing free? Which property makes the noble gas to exist freely? So 3 questions are there before we are going into laws. What? Kozal and Lewis chemical bonding. First question we can arise. What's the question? Why? What is the need of the atom to combine? Second one, if they are combining means how it is happening. Then why the noble gases are existing free? What property makes the noble gas to exist free? Okay, for these 3 answers, who is explaining, who is giving the answer means, who is giving the answer for this question? Kozal and Lewis. Okay, today we are going to see the explanation for this question which was given by Kozal and Lewis. The explanation given by Kozal and Lewis. Okay, so he explained with the help of the basic what he used means electronic theory of valency. Okay, on what basis he explained for these 3 questions means electronic theory of valency. Okay, or you can call that as octet rule. So the Kozal and Lewis, the scientist, in 1916 they start to explain the reason for these 3 questions. Why do atoms combine? How they combine? Why noble gas not? With the help of a rule, and they formulated a rule called as octet rule, or this rule can be also called as electronic theory of valency or electronic theory of valency. In the year 1916, the theory was put forward in the year 1916. The basic principle what they choose for explaining the answer for these 3 questions means this explained based on electronic configuration. So they are explaining the 3 reasons on the basis of electronic configuration. Okay, students, for we have 3 reasons why atom has to combine. For these 3 reasons, we are going to see the explanation given by the scientist Kozal and Lewis. He formulated a theory called as octet rule, or it can be also called as electronic theory of valency, in the year 1916. This theory is based on the electronic configuration. His explanation is based on the electronic configuration. Okay. When we see noble gases, if we see their electronic configuration, already we know, isn't it? K, element shells, subshells, and all we studied, isn't it? This noble gas, when we see the electronic configuration of this noble gas, they have stable electronic configuration. They have what configuration? A stable electronic configuration. What is that stable electronic configuration? When Kozal and Lewis analyzed the electronic configuration of this noble gas, they found that they have stable electronic configuration. What is that stable and unstable electronic configuration? According to Kozal and Lewis, these atoms, for example, helium, neon, krypton, argon, radon, these are the examples for what? Noble gas. See, for example, helium, that has only 2 and their valency also 2, isn't it? Only it has 1 shell, K shell. This K shell can accommodate only how many electrons? 2, and that 2 also completely filled. Okay, so they are stable. They are said to be stable. Next you see neon, totally it has 10 electrons. K shell 2, L shell 8. Outer shell contains how many electrons? 8. Similarly, if we view krypton, it also has outer shell how many electrons? 8. Like that, remaining all the noble gases, when they viewed the electronic configuration, the outer shell of the electron is called as what shell? Valence shell, isn't it? We studied the valency. So for each atom, the last shell, the outer shell of each atom, we can also call as valence shell, and the electrons present in that shell is called as valence electrons. So for the noble gas, all the valence shells are filled with 8 electrons. Okay, when we analyzed all the noble gases, what we found contain 8 electrons in the outer shell, and they are said to be stable, When we viewed the remaining atoms, for example metals, non-metals and metalloids, they have less than 8 electrons. So the valency for noble gas is 0. The valency for noble gas is 0. So they are already, the outer shells are completely filled and they are stable. They does not take part in chemical reactions. They are independent. These noble gases are what? Independent. Because outer shell has the enough electrons, 8 electrons, and they are stable. Remaining all the atoms, they have less than 8 electrons. They are said to be unstable. So to make them stability, these atoms, metals, non-metals, metalloids, these atoms combine with each other to form a molecules. As a result of combining, there will be creating a force that is called as chemical bonding. So Kozul and Lewis, from this they understood that no outer shell, if they have 8 electrons, that atoms are said to be stable and they will never take part in chemical reactions. They never lose electron, they never gain electrons. So their valency will be always 0. So this is the reason why the noble gas not taking part in chemical reaction. So they does not form any bond formation and they are independent. And always there will be monoatomic molecules. Monoatomic means single atomic molecules. Diatomic means oxygen combines with another oxygen to form O2 molecules. Then it is called as a diatomic. One atom, if it is combines with other, it can form diatomic, triatomic, polyatomic, etc. But always noble gas exists in monoatomic molecule. Whereas other atoms have incomplete valence shell. All other atoms, that may be metals, metalloids, whatever may be, they have incomplete valency. They have what? Incomplete valence electron. That means it has less than 8 electrons. So they are found to be unstable. So they have to depend on other atom to maintain their stability. Oxygen cannot exist as oxygen atom because oxygen does not have 8 electrons in the outer shell. For example, you can see oxygen, it does not have 8 electrons in the outer shell, less than 8. So they are not stable. So one oxygen combine with other oxygen and exist as oxygen molecules, or it can combine with any other metal or atoms or any other element to form a stable compound. So usually in the atmosphere, oxygen always combines with what? In the formed as a oxygen gas. It is present as a oxygen gas because as an atom they are not stable. As a molecule they are stable. So to form they have incomplete valence shell. To make a complete valence shells, they take part in what? They take part in chemical reactions. As a result of either these atoms transfer electrons or sharing. Okay, during chemical reaction, either transferring of electrons takes place or sharing of electrons will take place between the atoms. Okay, sharing of electrons or transferring of electrons takes place between the atoms. Okay, that means one atoms combine with other atom either by transferring the valence electrons from one to another or by sharing electrons between them. Anyway, they have to achieve what? 8 electrons in the outer shell. In order to that, they will combine. Okay, Okay, so noble gas is only present in monoatomic. Remaining all they have incomplete valence shells. to make complete shell or to make stable compounds, they will undergo chemical reaction. So one atoms combine with the other atom either by transferring the electrons between the two atoms or by sharing the electrons between two atoms, which forms a chemical bond. Okay, which forms a chemical bond. Okay, so anyway they have to attain what? 8 electrons in the outer shell, and they will become stable. In order to achieving 8 electrons like noble gas, they will take part in chemical reaction either by transferring electrons between them or by sharing electrons between them. Okay, hence only he gave this rule as rule of 8. Okay, rule of 8, or we can call it as octet rule, or we can call it as what rule? Octet rule. So Kozil and Lewis explained these 3 questions based on electronic configuration, and which rule is called as octet rule or electronic valency or rule of 8. So in order to achieving 8 electrons in the outer shell, these atoms what? They are combining with each other. How do they combine? Either by transferring electrons or sharing electrons. Why noble gas not combine? Because already they are obeying octet rule. Octet means what? 8. Already they have 8 electrons in the outer shell, so they need to combine with each other. Have you understood, students? Is that no? Okay. The next one is formation of sodium chloride. For example, I said no, they will combine with each other either by transfer. For that, a simple example we can see. For example, sodium chloride formation. Sodium is a metal, chlorine is a non-metal. Sodium has the electronic config 2, 8, 1. So this atom is not stable. They does not have 8 electrons in the outer shell. Outer shell has how many electrons? Only 1. So they are not stable. They have to combine with other element. For example, see here chlorine 2, 8, 7. They also have less than 8 electrons. So these 2 atoms are unstable. So they should combine. Okay. Sodium has to combine with either chlorine or any other element. Like that, chlorine also has to combine either with the sodium or any other element. Okay, for example, sodium not only combines with chlorine, any other metal or any other non-metal. Anyway, they have to get 8 electrons, or anyway they have to form a stable compound. See here, if you remove this 1 electron, then outer shell has how much? 2, 8. If this chlorine get 1 electron, it also become 8. So here also 8, here also 8. So only now chlorine is need of how many electrons? 1 electron. Sodium has excess 1 electron. So when they combine with each other, sodium transfer this 1 electron to chlorine. Sodium transfer this 1 electron to chlorine. Now the outer shell 1 shifted to chlorine. Now it has how many electrons in the outer shell? After removing 1, 8. Here after getting 1, it will get how much? 8. So sodium and chlorine, they exist as a single molecule. They exist as a single molecule called as sodium chloride. These two are held together by a bond, by a fold, that is called as chemical bond. So sodium lose 1 electron to, or sodium transfer 1 electron to chlorine and form a single unit molecule sodium chloride. So that both will get, or both will obey the rule of 8. Both will got 8 electrons and they will be stable in the atmosphere. See the diagrammatic representation of sodium and chlorine. This is the last shell 2, 8, 1, 2, 8, 7. So from here this excess electron is shifted, is transferred to chlorine. Okay. See here the last shell only I have drawn here. This is sodium, this is chlorine. This is the last shell of chlorine, this is the last shell of sodium. From here this electron is shifted to here. So what happened here means sodium lose electrons. We studied cations and anions, isn't it, students? Already you have studied about what? Cations and anions. When an atom, actually atom is what? First itself I explained at the beginning of the matter, while teaching matter itself I explained that atom is electrically neutral. Okay, but when there is an increase or decrease in the electrons, they will change us into ions. When a metal or when an atom, if it lose electrons, they get positive charge. When they gain electrons, they will get negative charge. Without losing and gaining, they will be neutral. Okay. So here, it lose one electron. From sodium, one electron is transferred to chlorine. Now here 2,8. So it lost electron. So they get one positive charge. Since they are losing one electron, they get one positive charge. 2 electrons means if an element lose 2 electrons means 2. 3 means 3. Here chlorine, first it is electrically neutral. Now it is getting one more charge, one more electron. So the charge changes into negative. So positive and negative force is created. Due to the transfer of electrons between sodium and chlorine, the force is created. What force created means electronic force, isn't it? That is electrovalent force. Electrical charge, positive and negative, always attract each other. So sodium always attracted to chlorine and they exist as a single molecule. So the bond is created between sodium and chlorine and they exist as a single molecule. Have you understood? So this is the bond. The charge, the attraction between sodium and, that is the attraction between positive and negative, which is called as electrovalent bond. Later once again we will see this electrovalent bond. Now for your understanding I am explaining that. So one atom combines with another atom by what? Transfer of electrons. So these two are held together by a force of attraction, that is called as chemical bond. What is the reason for combining? Sodium also unstable, chlorine is also unstable, but due to the chemical reactions they become stable. Usually metals, they will lose electrons and non-metals, they will gain electrons. Usually metals are lose, always metals are become cations and non-metals are anode. Or metals lose electrons and non-metal gain electrons. Usually the outer shell has, if they has 1, 2, 3 means they tends to lose. Those who have outer shell 5, 6, 7 means, did you understood what I am saying this? If outer shell, for example sodium 1 means they will lose. Magnesium has 2 electrons. Such element can also lose the electron. Aluminium has 3. They will lose electron. If they have 4 means they never lose. They cannot lose. They only undergo sharing. Okay, only the atoms outer shell which has 1, 2, 3 always lose the electrons, while the atom has outer shell 5, 6, 7 always they gain electrons. Usually metals will lose. 1, 2, 3 means maximum that comes under metal. 5, 6, 7 the maximum comes under non-metals. Clear students? Okay, metal lose electrons, non-metals gain electrons. Next one. Students, the next one is Lewis dot structure. That is, it is an electron dot symbol. Students, the next one is Lewis dot structure. This is nothing. This is just electron dot symbol to, see in the I have drawn, isn't it? While sodium and chlorine I put the dots for electrons. This is just to symbol the electrons that present in the valence shell. Okay, the Lewis dot structure, it is the symbol used for the electrons in an atom. The symbol of the element surrounded by dots representing the electrons of the valence shell. So for helium it has how many electrons? 2 means it was represented by 2. It was represented by 2 dots. Okay, 2 dots on either side. For example, hydrogen has only 1 electron in the valence shell, so 1 dot. So the electrons in the valence shells are represented by a dot. That is called as Lewis dot structure. For the unpaired electrons, we will use a single dot. For paired electrons, we will use double dot. This is example for paired electrons. These are the example for unpaired electrons, single electron. This is after the chemical reactions, they form paired electrons. The paired electrons means we will use double dot. For indicating a single electrons, we will use what? This dot means each, it is a representing the electrons. Okay, that's all. Lewis dot structure. Lewis dot structure, it is an electron symbol. It is just to note the electrons in the valence shell. Single dot means it's a single electrons. Unpaired electrons, paired electrons will be notified by double dot. Other than dots also we can use, the valence electrons can be used by cross. Okay, to differentiate we can use cross or you can use for dot. Okay, that is called as Lewis dot structure. Okay, That is the Lewis dot structure. So once again, Lewis dot structure, it can be also called as electron dot symbol. Okay, the Lewis dot structure, or you can call this electron dot symbol. It is used to indicate the valence electrons of an atom that present in the valence shells. Other than dot, we can also use cross, circle, cross, this like circle symbol also we can use to differentiate the valence electrons from other electrons. Okay, single, that is unpaired electron means single dot. If it is combines with other means two dots. A paired electrons are represented by a pair of dots, double dots, a pair of dots. Okay, so students, page number 149, page number 149. Here the words are there. Mark this question. It's a very important book back as well as book inside question. It's a very important question. What is octet rule? The tendency of atom to have 8 electrons in the valence shell is known as octet rule or law of 8. It's a very, very important question. So learn this question. The tendency of atoms to have 8 electrons in the valence shell is known as octet rule or rule of 8. Okay, students. Thank you, students. Learn this question. It will be asked for 2 marks. Thank you.